All right, everyone. Welcome to lesson 3 of our first science unit. You'll recall the last couple of lessons we talked about structures. Well, this unit is kind of about structures and forces, so let's talk about the second half. If you'll recall to the very first day, I asked you guys what a force was. What is a force? Well, if you think back or you look back, you'll find a force is a push or a pull. Right? If I shove something or pull on something, I'm applying a force to it. So, does the size of a force affect your ability to resist it? Does the direction of a force matter? Does the location of a force matter? Well, let's ask this first question. Does the size of a force matter? Right? If somebody pokes you with their finger, is that easier? Is it easier to keep still than if somebody tackles you? Of course, because the tackle is harder, right? You push harder, you will not be able to resist it as easily. Direction is another one. If I push down on you from above, you're probably like, on your shoulders from above, you're probably not going to go anywhere. Whereas if I shove you from the side with the same amount of force, you probably will move or at least stumble. So the direction does matter, right? Whether I'm pushing down on you or to the left or right. Does the location of the force matter? Well, yeah, it does, right? If I'm trying to open a door, if I push on the face of the door where the handle is, well, I could probably open it pretty easily. If I try to push on the thin edge and push on it, the door's not going to go anywhere. The door jamb will stop me. I can push just as hard and kind of in the same direction on the different faces of the door, but only one of them is going to make the door move. So the location also matters. And so we end up with this here statement. The effect of a force depends on how big it is, where you apply it, and in what direction you apply it. So forces are measured in something called newtons, right? The Newton is named after somebody named Isaac Newton. People like to say he discovered gravity, but he didn't really discover it. People knew that things fell to the ground for long before him, but he was the first to describe gravity. He described gravity using math and science, right? He was the one who finally said, this is how it works, right? And gravity is a force that is applied by the Earth to basically everything, right? It's the thing that holds your feet on the ground. It is pulling you toward the ground. It's why when you jump, you don't just fly away. All right? Gravity is always in effect if you're in Earth. Once you get into space, it gets a little more complicated. But when you're on or near the Earth's surface, gravity is always affecting you and always affecting everything else. So, your task for today is this page here. The title is Measuring Forces. There are 4 questions. The first one, you need to draw a big boulder. And I want you to draw an arrow pointing on to where you should push it to get it to move most easily. The second one, why does it take more effort to walk up a hill than it does to walk down a hill? Well, when you answer this question, Think about gravity. That is your hint. And that's kind of a hint for this whole thing. Make sure you're always thinking about gravity because it affects your answer to all of these questions, actually. If you're out walking on a windy day, what forces are acting on you? Name two. Name two things that are pushing or pulling on you when you walk outside on a windy day. The fourth one, you've got a man pushing a heavy box across the floor. I want you to draw a picture. That's what a force diagram is. Draw a picture of each of the forces acting on the box and label them with arrows, right? So if you've got somebody pushing the heavy box, well, the most obvious one is the man pushing. So you'll draw an arrow in the direction that the man is pushing. I want you to try to come up with three. Two of them are easy. The third one is a little more difficult. There's a couple different answers you come up with the third one. All right? If you don't get it, you don't get it, but I want you to try your best and try to think of things that are pushing or pulling in this situation, right? There are lots of things that are pushing or pulling. A lot of the time when two things are touching each other, they might be pushing or pulling. All right? That is your hint. It's a tough question, but I want to see if anybody can figure it out. All right? That's it for today. So until next time, best of luck. Take care of yourself. Have a nice day.